Welcome back to another video. Here, we'll talk about conditional probability in joint probability distributions. In the context of joint probability distributions, conditional probability distributions allow us to describe the probability of one random variable x given that another random variable y has taken a specific value. This conditional probability function provides the updated probabilities for x after observing y. The conditional PMF of y given x provides the updated probabilities for y after observing x, and is defined by dividing the joint PMF of x and y by the marginal PMF of given x. For continuous random variables, the concept is analogous, but applies to probability density functions. The conditional probability density function of y given x is the joint density function divided by the marginal density of x. It is important to note that conditional probabilities are normalized over the values of y, meaning the summation for discrete cases or integration for continuous cases of the conditional probability function of y given x over the domain of y equals 1. Let's go over an example together. Let the random variable x denote the time in milliseconds until a computer server connects to your machine, guaranteed less than 1 millisecond, and let y denote the time in milliseconds until the server authorizes you as a valid user, guaranteed less than 10 milliseconds. X and y measure the weight from a common starting point, and x should be less than y. Now, we're looking to find the conditional PDF for x given y, knowing the joint PDF and the marginal PDF of y. You can pause the video here and take a moment to answer this question. In order to find the conditional PDF, we need to divide the joint and marginal PDFs. The conditional PDF of x given y is 3x squared. Once we have the conditional distribution functions, we can easily derive the conditional mean and variance following these formulas. Now, we want to find the conditional mean of x given that y is equal to 10 for a continuous PDF. You can pause the video here and take a moment to answer this question. Previously, we derived that the conditional PDF of x given y is 3x squared. To find the conditional mean, we need to find the integration of x multiplied by the conditional PDF over the domain of x. As shown here, the conditional mean of x when y is equal to 10 is the integration of 3x cubed over 0 to 1, equaling to 0.75. Now, let's focus on a discrete case. We want to find the conditional mean of y given x is equal to 1 for this discrete distribution. The table is giving us the joint distribution of x and y. You can pause the video here and take a moment to answer this question. We start by finding the marginal distribution of x. To find p of x, we need to sum up the joint probabilities over the column for each of values of x. By doing so, we can see that probability of x being 1 is 0.2, that probability of x being 2 is 0.25, and that probability of x being 3 is 0.55. As the question is asking for conditional mean and variance of y given that x equals 1, the denominator in our conditional probability formula is always marginal mass probability of x being 1. For the numerator, we need to update it in each row based on the value of y. Conditional mass probability of y being 1 given x is 1 is the ratio of 0.01 and 0.02, where 0.01 ID the joint probability of observing 1 and 0.2 is the marginal mass probability of x being 1. Similarly, the conditional mass probability of y being 2 given x is 1 is the ratio of 0.02 and 0.2. The conditional mass probability of y being 3 given x is 1 is the ratio of 0.02 and 0.2. And finally, the conditional mass probability of y being 4 given x is 1 is the ratio of 0.15 and 0.2. Once we have the conditional probabilities, we can find the multiplication of each value of y by its corresponding conditional probability. The summation of these products gives us the conditional mean. So, the conditional mean of y given x equals to 1 is the summation of 0.05 plus 0.02 plus 0.30 plus 3, which equals to 3.55. The conditional variance can be calculated as the conditional expectation of y squared minus conditional mean squared. So, we need to find the conditional expectation of y squared first. To do so, we need to multiply the y squared with its corresponding conditional probability. The summation of these products gives us the conditional expectation of y squared. Now, We can easily find the conditional variance as the difference between the conditional expectation of y squared and the square root of conditional mean, which is 0.7475. Thank you for listening to this short lecture on conditional aspects of joint probability distributions.